For today's webinar, we have Mateo Serpentine from the Tarrant County, Texas Medical Examiner's Office presenting Glock Pistol Toolmarks, a literature review and introduction of undocumented toolmarks. Without further delay, here's Mateo.
Good afternoon. My name is Mateo Serpentine, and this presentation I'm going to discuss toolmarks produced by the Glock pistol, a review of the literature, and the introduction of two previously undocumented toolmarks. The goal of this presentation is to make the examiner aware of additional areas of interest for identification purposes, other than those traditionally used, such as the firing pin impression or the aperture shear. The marks that are going to be discussed were observed in Glock pistols, but could possibly be used for other make or model pistols with a similar design, and assist the examiner in identifying fired or unfired ammunition components to each other or to a suspect firearm. Now, a little bit of background on Glock pistols. As you might know, Glock pistols are probably one of the most recognized firearms worldwide. In the 1970s, Gaston and Helga Glock owned a small metal shop in Austria where they made curtain rods. Due to their high quality work and low cost, they got the attention of the Austrian Ministry of Defense, and they were contracted to produce field knives, bayonets, and machine gun belt links for the army. In 1980, the military was looking to replace their current sidearm, which was the Walther P38. At that stage, all the designs that were submitted for consideration did not help with the military's decision, and Glock overheard this conversation between two high-ranking officers. With the permission of the Minister of Defense, he was allowed to submit his firearm designs for consideration. Now, Glock, being very good with textiles, did not have any experience with firearms, so he started to accumulate 9mm firearms, and with the assistance of some law enforcement and other people that are knowledgeable about firearms, he started to design his own firearm. In 1982, Glock submitted 4 designs to the Austrian Army for consideration. Due to being lightweight, made mostly of injection molded polymer, and consisting of about 34 parts, Glock was awarded the contract for 25,000 pistols. This alone was a big feat for someone that just made his own firearm and beat the competition, which included Sig Sauer, Beretta, and Steyr. In 1986, Glock pistols were starting to be important to the US. In April of that year, there was a big shootout between the FBI and suspects that robbed banks and armored vehicles. It's known as one of the deadliest shootouts in the FBI's history. After the incident, the FBI concluded that they did not possess sufficient firepower to neutralize the threat. This is due to, at that time period, law enforcement carried revolvers instead of pistols. By fall of that year, police departments started to switch to Glock pistols from their duty revolvers. And by 1987, Miami Police Department ordered 1,300 Glock pistols. Now, in 1994, Smith & Wesson, being plagued by reliability issues and a low profit margin, wanted to get into the polymer firearm business, and they made their own firearm known as the Sigma series pistols in 9mm Luger and 40 Smith & Wesson caliber. Unfortunately, due to too many similarities to Glock pistols, Glock sued Smith & Wesson, and the case was settled out of court in 1997. This means that the early Sigma series pistols displayed similar class characteristics to Glock pistols, such as the rectangular firing pin aperture and the elliptical firing pin. The newer Smith & Wesson Sigma pistols, after the lawsuit, then displayed different class characteristics like a circular firing pin aperture and a hemispherical firing pin, which made it easy to distinguish it from Glock pistols. Now, in 2005, Smith & Wesson introduced their military and police, or M&P series pistols. All these pistols, except for the 45 auto caliber pistols, had a teardrop-shaped firing pin aperture. In 2014 and 2015, Glock also adopted the teardrop-shaped firing pin aperture for the Model 42 and 43 pistols, and said it would be a standard design feature for all their future models. Now, the reason why I bring up Smith & Wesson with Glock pistols is that due to their similarities between the Sigma series pistols and the newer Glock pistols with the M&P series pistols, multiple papers have been published discussing how the examiner can differentiate between these two firearms. It was during the research for these papers that multiple areas of interest were observed and documented. So, as mentioned in the title of this presentation, I'm going to discuss previously documented tool marks, which would include underside ejector marks, trigger bar tip marks, breech face recess marks, and ejection port marks on fired cartridge cases. The undocumented tool marks would be what I refer to as chamber lip marks and ejection port marks on unfired cartridges. Starting with the tool marks from the underside of the ejector, the authors of this paper noted some marks on the rim of a 9mm Luger cartridge in line with the ejector mark on the rim. Closer examination revealed that there's an interaction between the rim of the top cartridge in the magazine and the underside of the ejector in Glock pistols. Testing was done and it was confirmed that the marks that they did observe on the rim were produced by the underside of the ejector. These marks are created as the cartridge is pushed forward by the slide and under the pressure by the magazine follower scrapes the bottom of the ejector. The marks were observed on cycled cartridges and fired cartridge cases. Now, it should be noted that at the time of the publication, the authors only used 9mm Luger caliber Glock pistols because that was the most prevalent firearm that they received in casework. After a poster session at an AFTI conference, it was suggested that they look at different calibers, such as the 40 Smith & Wesson caliber Glocks. The authors obtained a 40 Smith & Wesson caliber Glock Model 22, and they could reproduce these marks as mentioned previously. The only difference is that the orientation of the ejector marks on the 40 Smith & Wesson is different from the 9mm because the ejector is straight, while the 9mm caliber firearms had a bent inwards ejector. It should also be noted that a new ejector part, Model 4340, was also observed in some Model 22 Glock pistols, and that this ejector is much shorter than the traditional one and does not actually touch the rim of the cartridge, which means you will not see those marks with Glock pistol having a new ejector part. So here's a photograph demonstrating the interaction between the tool and the tool mark. That's where the rim is scraping against the underside of the ejector. This is an oblique view for orientation purposes. This is a head stamp view, once again for orientation purposes. And to make sure that the mark that you're looking at is from the underside of the ejector, you can see that it is in line with the ejector mark on the head stamp. And this is what it would look like under the microscope. The second tool mark I'm going to discuss is from the trigger bar tip. Now, the trigger bar tip is the protrusion on the trigger bar that deactivates the firing pin block in Glock pistols. The authors noted strange stria near the ejector mark on the rim at approximately 3 o'clock position on a 9mm Luger caliber cartridge case that was fired in a Glock 17 pistol. The first thoughts when they saw these marks were that they were created by the extractor scraping over the rim to hook on the head of the cartridge. But with further testing, it was confirmed that the trigger bar tip was the responsible tool for these marks. In addition to the marks observed on the rim, there were also marks in line with it on the case body of the cartridge case. Testing also showed that these marks were created only during the firing process and not cycling. It was found that these marks showed enough individual characteristics to be identified to the suspect pistol. So here's once again a photograph to demonstrate the tool-tool mark interaction. Here's an oblique view showing the location of the observed marks on the rim and on the case body of the fired cartridge case, and a head stamp view for orientation purposes. It's close to the 3 o'clock position as it was noted earlier. And this is what it would look like under the microscope. The third tool mark I'm going to discuss is from the breech face recess. The author noted two sets of marks on the rim of a cartridge cycled through a Glock 19 pistol at approximately the 10 o'clock position. The first set of marks were already established as those being produced by the underside of the ejector. So the author set out to determine how and when the second set of marks were produced. Testing was done and it was confirmed that the marks were produced by the breech face recess of the slide, more specifically the lower left edge of the breech face recess. This is produced when the cartridge is stripped from the magazine, and once it clears the magazine lips from the pressure from the magazine follower, it pops upwards, striking that inner edge of the breech face recess. The marks were observed on cycled cartridges as well as fired cartridge cases, and the marks were found to be either impressed, striated, or both, and some are even similar in appearance to those made by bolt cutters, which would be the traditional V-shaped impressed mark with the striated marks extending away from the impressed. The marks may not be produced every time a cartridge is cycled, so if the marks are not observed on the rim, should not be construed as it was not from a Glock. Here's a photograph of the tool area. This is the underside of the slide, the circular button being the firing pin block safety, and that hook being the extractor. And this would be the lower left edge of the breech face recess. If you look closely, you can see there are brass deposits on that edge. This is an oblique view showing the location of the marks on the rim. Head stamp view to show for orientation purposes, and what it would look like under the microscope. The fourth and last tool mark that's previously been documented that I'm going to discuss is ejection port marks on fired cartridge cases. During a training session of a new trainee, the trainee observed marks on the mouth of a 9mm Luger caliber fired cartridge case from a Glock 17 pistol. Testing was conducted and it was confirmed that these marks are produced by the ejection port during the ejection of the fired cartridge cases. Testing was done with multiple calibers of Glock pistols, and the marks were observed on all of the fired cartridge cases. The marks displayed a characteristic triangular shape, or I've heard people refer to it as cyclone or tornado configuration, and is located at the approximately 4 o'clock position at the mouth of the cartridge case. Here's a photograph to demonstrate the tool and tool mark interaction. During the extraction and ejection process, the cartridge case strikes the inner lower edge of that ejection port, and that's where the marks are created. This is an oblique view showing the orientation of it. You can see the marks are at the mouth with a triangular shape, and is located at approximately 4 o'clock position, and what it would look like under the microscope. Now, the following tool marks that I'm going to discuss is undocumented marks that were observed from my personal experience. The first tool mark would be what I refer to as chamber lip marks. These marks are created as the cartridge moves from the magazine into the chamber. And the second one would be slide injection port marks on unfired cartridges. Regarding the chamber lip marks, some background on how I observed these marks. During examination of a routine case, a Glock 19 Gen 4 pistol with a magazine, a fired cartridge case, and unfired cartridges were submitted to the lab for examination. The fired cartridge case was easily identified to the pistol using traditional areas such as the firing pin aperture shear and the firing pin impression. During the examination and comparison of the fired cartridge case to test fire standards from the pistol, shallow striated tool marks were observed on the case sidewall, and it did not look like traditional chamber marks. Closer examination on the unfired cartridges also showed that these marks were on one of the unfired cartridges. Marks were arch-shaped, present in multiples, and separated by an unmarked space between them, and located near the mouth of the cartridge case. The orientation was at the 6 o'clock position on the cartridge case body. These marks can be described as almost like gills on a fish. This is what I observed. As you can see, that there are present multiples, arch-shaped, and separated with the space between them. Now, examination and comparison of these marks show that there's enough detail to identify them to each other. So, of course, the next step is to establish where and how these marks are created. My initial thoughts were that these marks could have been created by the forward lip of the magazine, meaning that as the cartridges are fed from the magazine, it scrapes over that forward lip, creating these marks. To test the hypothesis, I used the submitted magazine, firearms reference collection magazine, and loaded each with 2 cartridges and cycled it through the action of the pistol. In addition to this, I also used 2 cartridges that I manually inserted into the chamber and then cycled it through the action, extracting and ejecting it. Results from the testing revealed that the marks were produced by either of the magazines and they could be identified to each other, and no marks were produced with the manually cycled cartridges. This indicated 2 things to me: that the magazine forward lip was not the origin of the marks, and the marks were not chamber marks. They therefore had to be created from movement of the cartridge from the magazine into the chamber. So the next step I did was I stereoscopically examined the chamber area of the barrel. Closer look at the chamber area revealed a raised lip right between the feed ramp and the chamber itself. The lip is essentially just the lower starting edge of the chamber. A closer examination revealed brass deposits on this raised lip. Using Papermate liquid paper, which is a typing corrective fluid, I used the unfired cartridge and cycled it through the firearm, and the paint transferred to this lip, indicating that this is the origin of the observed marks. Now, since it was a Glock 19 pistol I received in casework, I took some Glock 19 pistols from our lab reference collection and evaluated whether these marks were produced by other Glock 19s. Before testing was started, each pistol was cleaned, and the cartridges that were used for cycling and firing were examined to make sure that they were devoid of any reloading, cycling, manufacturing marks that could influence the examination. The testing involved 4 Glock pistols from different generations. 4 cartridges were cycled through each pistol using their respective magazines. 3 cartridges were fired in each pistol. And during testing, only 1 cartridge was loaded in the magazine at a time. The cycle cartridges and fire cartridge cases were then examined and microscopically compared. The results showed that the marks do not always produce, but when they are produced, they could be identified to the responsible Glock pistol. That can be created by multiple generations of Glock 19 pistols, and they can be created on both fired and cycled ammunition components. So the next step for me was to see if other Glock pistols in different calibers or models can create these marks. Multiple calibers were obtained in different models, which would include the 380 auto, 9mm Luger, 40 Smith & Wesson, 10mm auto, and 45 auto. 3 firearms from each caliber were selected, except for the 10mm auto, due to limited availability of that caliber pistol and ammunition. 3 cartridges were cycled through each pistol, once again loaded 1 at a time in the magazine, except for the 10mm auto, which, due to limited availability, only 2 cartridges were used. Once again, before testing was done, all the pistols were cleaned and the cartridges were examined to make sure they were devoid of any markings. The testing results show that the chamber lip marks can be produced in multiple caliber Glock pistols. It was found that the 9mm Luger caliber pistols consistently produce the best quality marks that could be identified to a specific pistol, and the marks that were not observed on cycled 40 Smith & Wesson and 45 auto caliber cartridges. This is a representation of identification on a 9mm Luger Glock, on a 10mm auto caliber Glock, And as you might see that this cartridge case is the nickel-plated cartridge case, and the previous one was brass, which shows that you can see these marks on different composition cartridge cases. Some preliminary testing showed that steel-plated or steel cartridge cases that's either lacquered or poly-coated do not produce these marks well. And it's also very difficult to see it on aluminum cases, but you can still see them, if they are produced. This is an example of a 380 auto identification. So after comparison was done between cycle cartridges from each firearm, they were intercompared to see if there could be a possibility of a misidentification. After intercomparison was done, it was found that all the patterns were different and had different individual characteristics, making the possibility of an incorrect identification low. This is what I observed as my best known non-match, which means it's the closest I could get knowing that these are from two different firearms. So now all my previous testing that I did was with one cartridge loaded in the magazine at a time. The next thing that I would like to do was load a full magazine and cycle it through a Glock 19 Gen 4 pistol to see if the location of the cartridge in the magazine could affect the production of these marks. The cartridges were each marked to establish their location within the magazine. The magazine was loaded, inserted, and all the cartridges were cycled through the pistol. The results from this test showed that all the cartridges had the chamber lip marks, which indicated that the location in the magazine did not have an effect on the production of the marks. So of course, we have to make sure that there's no subclass influence when we say that it is an identification. So the next step I did was visually examine the feed ramp and the entrance to the chamber to look at the machining marks. The feed ramp of the Glock pistols used for testing were examined, and some of the feed ramps had apparent grinding or honing marks running perpendicular to the feed ramp, as can be seen in this photograph, the feed ramp being 6 to 12 orientation and the marks running from 9 to 3. While other Glock pistols had a granular appearance that was most likely due to the finishing processes such as sandblasting, tumbling, and coating applied by Glock. The chambers were inspected and they had apparent reaming or honing marks that ran perpendicular to the axis of the bore. The chamber lip represents the intersection of these two separate machining operations. So as the cartridge is traveling up the feed ramp into the chamber, it's running perpendicular to machining marks. Based on this examination, the potential for subclass in chamber lip marks was found to be extremely low. These marks are produced by randomly occurring imperfections, and if reproduced, can be used for identification purposes. So in conclusion and summary of the chamber lip marks, the marks can be reproducible. The marks can be used for identification purposes. The potential for subclass is extremely low, and magazine spring tension does not affect the production of the marks. Now, due to the limited number of pistols used and only focusing on Glock pistols, the potential for these marks to occur in other 40 Smith & Wesson or 45 auto caliber Glock pistols or any other brand of pistol with a similar design cannot be excluded. Some examiner caution here: since these marks can be produced through either cycling and or firing, the examiner just have to make sure that when they are using these marks that they are not interpreted as fired in, but that they could be both fired in or cycled. Last marks I'm going to discuss is the slide ejection port marks on unfired cartridges. So once again, the initial observation of these marks were the examination of the cartridges that I used to evaluate for the chamber lip marks had these additional marks on them. The marks were on the edge of the cartridge case mouth, and sometimes it was on the bullet. The marks were slanted to the right and mostly had the appearance of a gouge mark or an impressed mark. This is a visual representation of what I saw. As you can see here, there's a gouge mark on the edge of the cartridge case and on the bullet itself. Now, based on the location where these marks were observed, the hypothesis was that they were created by the slide ejection port. So to test the hypothesis, once again, I used paper-made liquid paper and I put it on a cartridge, cycled it through the action, and then the paint transferred to the inner edge of the slide ejection port, indicating that that's where the marks are from. Here you can see it's the slide ejection port with the paint transfer where the cartridge hit the lower edge. This is a demonstration of the tool and tool mark interaction. Using the cartridges from the chamber lip marks, these cartridges were also examined and compared to each other. This is just a quick snapshot of the data collected. And the findings from the comparison between these cartridges were the following. They were located at the approximate 4 o'clock position, just the same as the ejection port marks and fired cartridge cases. The marks are slanted to the right and can be on the cartridge case, the bullet, or both. Sometimes there were shallow marks, striated marks in the approximate same location, but those marks can still be used for identification purposes. I also found that it was possible to identify a fired cartridge case ejection port mark to a cycled cartridge ejection port mark. Testing showed that the bullets did not mark as consistently as the cartridge cases. And once again, just like the chamber lip marks, the 9mm Luger caliber cartridges consistently displayed the best quality marks for identification purposes on both the cartridge case and the bullet. And since these marks are impressed marks, there are two sides or two planes of the mark to use for identification purposes. And later on, you'll see a photo of what I mean with this. Uniqueness was already established in the previous article regarding the ejection port marks and fired cartridge cases. And also intercomparison of the marks from the pistols did not result in an identification. So here is a slide ejection port mark on the edge of the cartridge case from a 380 auto Glock. On the cartridge case again from a 9mm Luger. And here's a representation of the marks being on the bullet and the cartridge case edge. As mentioned, the 9mm Luger caliber Glocks had the best quality marks. This is just a close-up of a mark left on the bullet. Now, during the examination of the 9mm Luger caliber cartridges, it was observed that sometimes they were striated marks with or without a gouge mark. The comparison of the striated marks to the gouge marks still resulted in an identification. So in this picture here, you can see the cartridge on the left has got a very shallow impressed or gouge mark with clear striated marks right next to it to the right. And the cartridge on the right has got that distinct impressed gouge marks on the bullet and the cartridge case. This was the comparison of the striated marks on the left cartridge to the gouge mark on the right cartridge on the bullet and on the cartridge case. As mentioned earlier, it was also possible to identify the ejection port marks from a fired cartridge case to a cycled cartridge. The fired cartridge case being on the left and the cycled cartridge being on the right in this photo. Once again, another identification of the ejection port mark on a 40 Smith & Wesson Glock. Here's it on the 10mm auto Glock. And as you might have noticed, most of these marks are striated in the gouge mark. But what I observed with this specific cartridge, when I rotated the cartridge to the right, I looked at the opposite end or the opposite side of the gouge mark, which had a granular appearance, which could also be used for identification purposes, almost like the comparison of an impression in the firing pin. Once again, an intercomparison was done between all the cartridges and no identification was possible, this being the closest I could get of a known non-match. So in conclusion and summary, A review of non-traditional marks gives the examiner some extra tools in their toolbox for identification purposes. As examiners, we usually rely on just the firing pin aperture shear or the breech face or firing pin impression. The marks related to the chamber lip marks and ejection port marks on unfired cartridges can be reproducible, unique, identifiable, and can be used to identify cartridges or fired cartridge cases to each other or to a suspect firearm. The presentation was focused on tool marks that can be used to identify these components to a specific Glock. And it also needs to be noted that this does not include the possibility that the reported tool marks may or may not be created by another make or model pistol with a similar design. This is a list of my references. And I am open to any questions at this point.
All right. Thank you, Matteo, for such a wonderful and fantastic presentation. Let's go ahead and get right into some questions from the audience. First one that I have here. To your knowledge, are there unique tool marks associated with cartridges that have been jammed in the chamber?
Well, if this is in reference to a Glock pistol, I'm not sure, because I mean a jam can usually indicate different things, but I suppose you'll have to look at has the firearm been altered? In what way did the cartridge jam in the chamber? So I mean, I guess if there's something odd about it, let's say it's not a very finished firearm, there could be marks. It depends on how it jammed in the chamber.
Understood. Yeah, I know it's kind of a unique situation, considering a jam could be caused by a multitude of things and could cause the round to position itself in a number of ways. So it's probably pretty unique to each individual circumstance. Do you know of any kind of common jams or malfunctions that might be persistent to some degree, or is it usually pretty random?
Well, I mean, once again, if it's to Glocks, I've rarely found a jam with a Glock.
Mm-hmm.
But once again, it just depends on, if we're talking about firearms in general, it could be a faulty magazine. There are different things to take into consideration when you do get a consistent jam in a firearm. And I mean, that's why we have to test each firearm in the condition we received it and try to recreate the scenario. And then once we recreated it, then we can kind of see and establish why and how these jams occur and evaluate how these marks are created. So I would say it's on a case-to-case basis. In general, I don't think I can say really in general, what causes the jam.
Sure. Sure.
Other than obvious stuff like, limp wristing would cause a stovepipe.
Mm-hmm.
But since we're talking about the marks themselves, it's hard to say.
Sure. Absolutely. Another question I have here, and that you brought this up in your presentation a little bit. So definitely as far as Glocks, do you have any theories as to why certain calibers leave more pronounced marks than others? Is it just because of the difference in size, or are there other factors that could be at play?
I'm not sure, but what I'm thinking is because it wasn't observed in the 40 and the 45, it might be a different finishing or manufacturing process that does not quite create that lip, the chamber lip mark, or it could be that the angle that the cartridge is fed into the chamber is different, like the ramp is at a different angle, making it, I think, shallower, or it could be both. I'm not sure, but that's my thinking process at this stage.
Sure. Kind of going into actually with the ramp marks and the chamber lip marks, I know you talked about this in your presentation, but could you go into detail again about how you determine the difference from a feed ramp mark to the chamber lip marks?
Well, the feed ramp marks ran horizontal to the feed ramp, so and then they're very, very shallow. Usually, when marks run perpendicular to the machining marks. They're considered unique because you don't have to worry about subclass and stuff. But during the testing, like I said, I put like paper mate liquid paper, which is like a corrective fluid. And once I applied it to the cartridge that I cycled through the action, that's where the paint transferred to us, to the chamber lip mark, and not on the feed ramp. I also think it's because the feed ramp is relatively smooth, and the chamber lip is a small protrusion, which basically scrapes the cartridge. So that's how I determined the difference between those two, because the paint didn't transfer to the feed ramp, and it's relatively smooth compared to the chamber lip itself.
Gotcha. So back to kind of different types of ammo. We have a question here that I don't remember you mentioning in your study, but maybe you have some experience with this in some capacity. Do you know if reloaded ammo has any effect on the markings and how pronounced they are?
I have not checked anything with reloaded ammunition, but I would guess that since it's the same mechanism that works with it, obviously the examiner just needs to be cautious to establish that these marks are from the chamber lip mark and not a reloaded mark from something else. But I would think it would be the same result, since the action, how it proceeds or moves into the chamber, is the same.
Sure, absolutely. And then kind of in the same line with just variations on what you discussed. And again, I know you didn't specifically talk about these, but I'm curious, and the audience is curious, if maybe you have heard anything, read anything, or have any experience with some variations on this. Like, for example, that, Glock and the majority of guns have aftermarket direct replacement parts that might have similar tool marks, but it might introduce some new variants. Do you know if there's been any testing done with the replacement trigger bars or housing barrels, any of that type of aftermarket change outs for the original gun?
I didn't do any testing. I mean, I took stock standard Glocks as is. Once again, that's just, you have to assess each gun as they're produced and their class characteristics in that sense. For example, the trigger bar making marks on the cartridge case itself, you have to see if there's an interaction between the tools. But as far as the Glocks go, I haven't done any testing or research on polymer 80s or something similar. But I think that's just, you have to do individual testing for each firearm if you think that there's an alteration or anything like that.
Sure, absolutely. And again, the variants and how many different aftermarket replacement parts and whatnot, I'm sure it's a wide range of things to have to test for and account for.
Yes, and like I mentioned, it's I observe these marks in Glock pistols, but if the firearm that's not a Glock or a polymer 80 or something that's similar to a Glock could potentially create these marks. So I guess if you see them, it's a good starting point to know that, okay, I need to look at the chamber lip marks or the ejection port marks. But to be scientific, you probably have to do some individual testing to just confirm that it is indeed the marks that you're looking at.
Right. Kind of start with the systematic approach first, and then see where it deviates from that based off of the situation.
Yeah.
Going more into variation there, I know that seems to be the big topic of questions in the audience. Did you have, and I apologize if you mentioned this in your presentation, I may have missed it as well. Did you have the opportunity to test different generations of Glocks, or was it all the same generation that you used?
No, I use different generation Glocks in different calibers. Like I said, the big difference that I saw was just with the 40 and the 45 caliber. And like I said, my train of thought on that is basically the angle of the feed ramp itself might be just a little bit shallower. So when the cartridge is fed into the chamber, it doesn't, scrape that lip, or the lip is just so shallow or diminished from finishing or manufacturing process that it didn't show up. But as mentioned in the presentation, it's testing on limited firearms. That's why I also mentioned that it can be excluded that 40 or 45 caliber Glocks could create these marks. But from what I've seen in this study so far was that I didn't see them on those two calibers.
Sure. Next question I have here. Do you think the brass deposits on the start of the lower edge of the chamber could be used to link to the cartridges in addition to the tool marks? Well, actually, I'll start there. This is a two-part question, but I'll let you answer that one first. So, yeah, do you think the brass deposits on the start of the lower edge of the chamber could be used to link the cartridges in addition to the tool marks?
Yeah, I'm not quite sure what the question would be, since a brass deposit will just indicate that brass ammunition was scraped over that edge. I don't think comparing, you take a swab of the brass and you say, okay, the brass is consistent with the brass from this ammunition. I don't think that's a possibility.
Sure.
But if we talk about and this is, once again, it's in a limited universe situation where this is a very clean gun, and you have nickel plated or poly coated, or different types of composition that could leave different types of deposits. I mean, you can get some information on that, but connecting it just on the fact that there's a brass deposit to a cartridge, I don't think that's possible.
Sure. And actually that kind of leads into the second part of this question, but it may be trickier to pin down this part, but to that end of, a lot of these firearms are not used just once, or up until that point has never been used or fired or is clean, a multitude of variables. What about that might have some impact on the markings that are used? Like, for example, if it's an older, not well kept firearm, not well kept Glock, do you think that would have any major impact on the tool marks, or maybe be something that could be utilized as a way to identify the gun to the casing? Have you read anything or had any experience with that?
Well, I mean, tool marks is basically created from a harder surface getting in contact with a softer surface, and the harder surface would leave marks on the softer surface. Well, in this case, would be as the brass deposits. There could be an accumulation of brass, but the testing that I did was on new, or not new guns, but clean guns. It's hard for me to say. I mean, you do get firearms that's been fired a lot. You get, especially if you look at the revolvers and stuff, you get a buildup of lead in the barrel that could obscure marks. I would probably have to do some testing to see, if I fire 100 or 200 or whatever amount of cartridges in a Glock pistol, if it would actually get to a point that it the deposit builds up so much that it obscures the marks. But at this time, I can say, since my testing was only done on clean pistols.
Sure, absolutely. Yeah, no, we're just talking in the realm of hypotheticals here.
Yeah.
So kind of opposite end of the spectrum with talking about older guns and ones that have been used quite a bit, or just older generations. Again, talking about hypotheticals, do you know of or heard of any kind of new firearm manufacturing techniques or new engineering in those processes that may lead to changes in these tool mark findings? Like, with new generations of Glock pistols, may there be things that tool marks that have been showing up for years, or showing up consistently in multiple generations, that all of a sudden may not, or anything similar to that may require some revisiting of these tool marks?
Well, not that I'm aware of at this stage. I mean, absolutely, a manufacturer can decide, okay, we're going to implement now metal injection molding for this part instead of broaching or grinding, or change the manufacturing process. But you also have to take into consideration the interaction between the tool and the tool mark. So, as long as that stays consistent, and you can establish that the manufacturing process could lead to unique marks, I think you can still use those. But who knows that the manufacturing process has changed, that, say, for example, they get rid of the chamber lip mark, then back to square one, basically.
Sure. And again, it's not like all of a sudden all the guns that are in circulation get thrown out when a new one comes into the market. So it's not like it would be a complete scrap, but more so just a pivot to also accommodate or account for those new variations, which sounds like in itself might be a way to identify at least to some degree. Another question, kind of going back into the different types of ammo. And I know you alluded to this a little bit with the makeup of the casing. Would the tool markings show a slight difference between steel casing compared to brass casing?
Well, most of my testing was done on brass casings and nickel-plated cartridge cases, but right before this presentation, I did cycle a few poly-coated steel, like Tula ammo cartridges, and the marks were not well defined on them at all, which would, once again, a steel casing is much harder than a brass casing. So, I did see some slight marks, but I couldn't really find any good marks to identify. So a steel casing might inhibit the identification of these marks just because it's a harder surface.
Sure. No, that makes sense. So we're getting to the top of our list of questions that we've kind of accumulated while we've been chatting, and just wanted to first take this opportunity to ask the audience, please continue to send in any questions that you have. We still have plenty of time. We'll definitely get them in front of Mateo and talk about it before we end today's webinar. But while we're waiting for them to send any more questions, I wanted to ask you, Mateo, do you have any plans, or what are you thinking as far as your next kind of phase of research, at least even at a high level, after working through this particular study?
Well, I mean, personally, I've never examined a polymer 80 or these new ghost guns that come out, and from what I gather, it's getting rather popular. So I might actually try and find some polymer 80s and do similar research on that. I recently submitted half of this presentation for publication just on the chamber lip marks, and then I'll probably finish up and submit the second half of this presentation, if you may, the ejection port marks and unfired cartridges. But I mean, from these questions, it seems like like the buildup of brass deposit. I really don't know. So that might be something that I could look at. Take a firearm that I know has very distinct marks that's easily observed, and then fired it. Barring that we can get enough ammo. Shoot it and see if there's actually a change between 0, 1 shot, 5 shot, and shot 100 or something like that. So I think that might be a starting point if I continue on this road with this type of research.
Yeah, absolutely. And to your point, it is definitely a topic of conversation in the chat, because we also, as you were talking, we just got another question more or less covering the same thing we just talked about, with just traditionally most firearms used in crimes that are being investigated are older, or not well kept, not well maintained. And somebody asked about, old guns whose barrels are corroded or misformed in some way. So again, we already talked about that, but it seems like there might be some value in looking into those variations with I don't know, maybe closer to real life situations with how some of these guns are not well maintained.
Well, I mean, I think it's a two-part thing. There's a difference between like a variation with corrosion or misuse or abuse or altering, and between, let's say, the buildup of brass deposits or something like that. I just think that confirms again that when we do get a firearm in for testing and evaluation, you should do it in the condition that you received it, and make multiple test exemplars, casting or test fires or something like that, and see because then you keep the firearm in the closest condition that it was received in. And then, maybe after that, clean it a little bit and see if there's changes, or, in the sense of something that's being altered, that could be easy because, usually that would make, say, for example, where a process from the factory has a smooth surface, by this person altering it roughed the surface up, creating it or making it more unique. So I think it depends on what type of components you look at, and if it's just a dirty gun or a altered gun. But I think that's basically the only advice I can give is test it as received, and then by using the scientific method and working slowly, step by step, try and figure out how these marks were created and where they're from and why they're different.
Sure, absolutely. Well, I think we've had a couple of questions come in, but I know we've already covered those topics, especially with the bullet weight and the cartridge size and how that has some variation on the how pronounced the marks are. And I know you also obviously mentioned in your presentation kind of the consistency of the markings on your test fires. I don't know if you want to go in real quick into those details again on like just the consistency of the markings on your test fires and if they showed up with every test fire or where you saw some sort of deviation from that. Were there any key parts that you want to reiterate about kind of your findings and the consistency of the tool marks coming in as more and more test fires occurred?
Well, when the calibers I tested, like I said, the 9mm Luger on both the chamber lip marks and the ejection port marks had the best quality marks. I think, bullet weight, I think it more depends on how hard you rack the slide when it hits the hits the ejection port mark in that sense. Just like the ejection port marks, they're striated marks because there's no weight to the cartridge case mouth, but with the bullet in it, there's some weight to it. And I don't think there'll be a big difference between 115 grain and 124 grain bullet in 9mm when you do it. I think it is more reliant on how hard the slide is racked for it to strike that edge. Chamber lip marks, it was, except for the 40 and the 45 that I didn't observe anything. You see it here and there, but it's not as consistent as the 9mm Luger. So multiple tests are definitely a good thing to consider when looking at these marks. Like I said, some of them are hit and miss. I'll see, say, for example, 2 marks, but I couldn't identify them to each other. So I would document, okay, I did see these marks, but I couldn't identify them to each other. So I think it just stresses the importance again of making multiple test marks and then evaluating it on that.
Sure. Yeah. So it sounds like it overall, again, kind of just best guess, best hypothesis is really the prevalence or how pronounced the toe markings are more so related on like the operators kind of variance in how they rack the gun and how they use it as opposed to the composition of the bullet, although there seems to be some sort of indication of a variation in certain calibers. And again, but it still kind of goes back to, well, certain calibers may get racked in a certain way differently depending on that user and whatnot. It still kind of falls back to the operation of actually bringing the bullet up the magazine and into the chamber.
Yeah, and like I said, also in the same firearm, I use, say, for example, 3 or 4 tests, and then some of the tests will not have the mark on the bullet, and some tests will have the mark on the bullet and the cartridge case. But once again, just the 9mm Luger just had the best quality marks, and I can't really say it's all the time or every time, but multiple tests would be a good option to make sure that you can see these marks and compare them.
Sure. One more question I have here. Obviously Glock is one of the more popular and more widely circulated weapon or gun manufacturer pistol types that are out in the field. Do you see either you personally or just from research or reading, do you see any other types of manufacturers that would be worth having a similar type of study or review done based off of just their prevalence in investigations?
It's like I said at the beginning of this presentation, there were a lot of similarities between the older Glock pistols and the Sigma series pistols from Smith & Wesson, and then Smith & Wesson changed their class characteristics, and then Glock also changed theirs to make it look similar again. So, who knows where manufacturers will go? They might change their class characteristics to be similar to what we've seen now, and say, for example, the Smith & Wesson M&P series and the new Glock series with the teardrop shape. I think Taurus has now got a pistol that's also got a teardrop shape. So I think it's hard to say which one would be prevalent. We don't have a NIBIN unit or anything here at Tarrant County, but I bet a lot of people with NIBIN and stuff would probably have a better answer on which firearms are more prevalent to look at. But like I said, it's once again, if it's a similar design Glock pistol, do the testing, and hopefully this presentation can give you basic guidelines to look where these marks are created if you do see them and they look the same as the ones that I just showed.
Sure. Well, I think we're going to have to start wrapping up here. And before we start closing things out, I just wanted to not only say thank you, Mateo, but also just give you the floor. If there was anything else that you wanted to highlight or reiterate, please feel free.
No, I just want to thank you for the opportunity to do this. And, AFTI and the firearms community is so great, where everyone wants to help each other, because, I mean, we're all fighting for the same team. And it's just an honor to be a firearms examiner. And I hope I can do this for many years. And I appreciate all the help from all the firearms people that I've been in contact with.
Awesome. Well, and I have to say, and again, I did not come from this field, and I am not especially a firearms examiner by trade or anything. It's just from what I can learn from these webinars. And I got to say, the use of the liquid paper to see where the transfer and the markings actually rub up against, if that was an original idea or even just an idea that somebody suggested, I gotta give kudos to the ingenuity there, because that's just a genius way to try and track where those things are touching up against each other, with using a material that's pretty easily accessible and cheap, that's in an office setting.
Yeah, no, it's a tried and true method. A lot of people before me has done it, and that's from reading articles and stuff. That's just how I also use that. It's simple, easy. It doesn't damage the firearm, and obviously you can just use acetone and wipe it off, and there you go. It's
perfect. Well, again, thank you for taking the time out of your day to present and answer questions. It's been extremely valuable. Great responses from the audience. So Mateo, thank you again for taking the time to provide such an informative presentation.
You're welcome. Thank you.
Before you leave today's webinar, we ask if you could participate in a short 5-minute survey. You will see a checkbox icon directly above the chat. Simply click that button to be linked to the audience feedback survey for today's event. Your feedback about our webinars is critical information that helps us improve and continue to provide you the best webinar experience possible. If you could please take those few moments to complete the survey, we would greatly appreciate it. Lastly, across the top of the live stream window are links to all our social media profiles, including Twitter, LinkedIn, and Facebook, a link to our website at forensiccoe.org, and a link to listen to episodes of the FTCOE's podcast, Just Science. There's also a link to sign up for the FTCOE newsletter, so you can stay up to date with everything that FTCOE is doing in support of the forensic community. Thank you again for attending, and we hope everyone has a great day.